This humanoid robot is doing things that barely seem real. In the latest demo, Atlas rotates its torso a full 180 degrees, squats down, lifts a mini fridge, and casually carries it across the room to an engineer. But the really impressive part isn't just the movement you can see on camera. It's the way the robot uses its entire body together, almost like a trained athlete, to handle a task that would actually be difficult for many people. The team behind Atlas isn't building a robot just to perform cool tricks. Their goal is to create a machine that can handle physically demanding jobs in factories, warehouses, and construction sites. Other robots from the company already take on tough work every day. Stretch unloads heavy boxes from trucks in extreme heat, while Spot performs repetitive inspections in industrial environments with incredible consistency. Atlas is meant to go even further by becoming a general-purpose robot that can handle real physical labor. What makes this new version of Atlas stand out is how naturally it moves while dealing with heavy objects. Instead of relying only on its hands, Atlas uses its arms, torso, legs, and even body positioning to balance and support weight. That's something humans do automatically, but teaching a robot to move that way is incredibly difficult. The developers say real-world work requires more than just vision and precision. Humans don't lift heavy furniture by simply looking at it. We lean into objects, adjust our grip, shift our balance, and react to how the weight feels. Atlas is being trained to do the same thing. The robot learns through reinforcement learning, which basically means it practices tasks millions of times in simulation until it figures out the best way to adapt. For the fridge lifting demo, Atlas trained with countless virtual versions of the fridge. Some were heavier, some lighter, some positioned differently, and some had different friction on the floor. The robot learned how to adjust to all those changes without needing an engineer to manually program every movement. Instead of memorizing one perfect lift, it learned how to react to unpredictable situations. One of the most fascinating parts is that Atlas relies heavily on proprioception, which is basically body awareness. Humans constantly sense where their limbs are and how much force they're using. Atlas is learning similar behavior, allowing it to adapt while it's actually interacting with an object. That's why it can hug a heavy appliance against its body and adjust its posture while moving. The hardware itself is also very different from older humanoid robots. Atlas was designed to be simpler, stronger, and easier to scale for mass production. The robot uses only 2 types of actuators throughout its body, which makes manufacturing and maintenance more efficient. Its arms and legs are symmetrical, many parts are interchangeable, and even the joints can rotate continuously because the design eliminates cables that normally wear out over time. The robot's feet are symmetrical too, meaning Atlas can move forward and backward equally well. Even more impressive, major parts like the hands, arms, legs, and head can be swapped out within minutes. That kind of modular design could make repairs much faster in industrial settings. The company also says Atlas isn't just about carrying heavy loads. Some of the flashy moves, like handstands and backflips, actually help improve the robot's agility, balance, and recovery skills. A robot that can recover from slips, awkward positions, or sudden shifts in weight is much more useful in the real world. Training Atlas happens at incredible speed. Engineers can create a movement in simulation, train the robot on millions of virtual attempts using GPS, and then transfer that behavior onto the real machine. The process starts with a reference motion, sometimes just a simple animation showing what the robot should do. Then rewards are added, so the AI learns which actions lead to success. After enough simulation training, the behavior gets tested on the real robot. The developers openly say their approach is build it, break it, fix it. Real-world testing exposes problems simulations can't always predict, so the robot constantly improves through repeated iterations. One major breakthrough is how closely the simulations now match reality. In robotics, there's usually a sim-to-real gap where something works perfectly in simulation but fails on actual hardware. Atlas has reportedly reduced that gap dramatically. What works in the virtual world now behaves almost the same on the real robot. To make Atlas more reliable, the training environment is intentionally unpredictable. The robot practices with different weights, floor conditions, motor strengths, and shifting loads. In one test, Atlas successfully moved a fridge weighing over 100 pounds, even though it trained on lighter loads. The weight inside the fridge wasn't balanced either, but the robot adapted in real time. Even the robot's hands are designed for serious durability. The grippers used in these demos are strong enough to support the robot's entire 198-pound body weight during gymnastic movements. And according to the developers, even more advanced dexterous hands are already being tested behind the scenes. Atlas still looks futuristic, but what's really exciting is how quickly it's evolving. The combination of advanced AI training, highly accurate simulation, and practical hardware design is pushing humanoid robotics much closer to real-world use. Instead of just being a research project, Atlas is starting to look like a machine that could one day work alongside humans in demanding environments every single day.